Hey guys, welcome to today's numeracy tutorial. In our last lesson, we explored subtracting fractions. Today's lesson will focus on developing this further. We will explore subtracting from fractions greater than 1. But as always, let's get warmed up with our 5-question brain gym. Here are your 5 questions. Pause the video and give each one a go. Question 1 asks you to compare the two fractions to find the difference. The difference between 12/7 and 6/7 is 6/7. We can see a fraction sequence in question 2. It is in ascending order, meaning it is increasing. I notice the numerators are increasing by 7 each time. The next two fractions in the sequence are 28 hundredths and 35 hundredths. In question 3, the area of the rectangle has been split into 2 colours. Remembering that area is the space inside a shape, I can count the blue squares and the orange squares to find the area of each. The area of the orange space is 5 squares and the area of the blue space is 7 squares. Question 4 gave you practice at dividing a 4-digit number by a single digit. The quotient is 769 with a remainder of 2. And question 5, as normal, is your time question. You will notice the minute hand is pointing to 8, meaning the time is 20 minutes to the next hour. In words, we write 20 minutes to 11. Digital time is always shown as the number of minutes past the last hour, so it is written as 10:40. It is 40 minutes after 10. Now we are ready to learn. Let's get started with today's learning objective: subtracting from fractions greater than 1. Francesca has been busy baking with her friends. She's weighed her bag of flour to discover she has 1¼ kilograms. She wants to know what the mass, in other words weight, of the flour is after 3/4 kilogram is removed. We will subtract to find out. 1¼ is reduced by 3/4. First I will illustrate the original weight, 1¼ kilograms, using a bar model. I know that I have one whole bar shaded and a second bar split into 4 equal parts, with only one part shaded. I must reduce this by 3/4. Here I'm showing all parts of the whole bar model. Notice that 1¼ is in fact equal to the improper fraction, 5/4. So I can change my subtraction equation from a mixed number subtracting a fraction to a fraction taking away another fraction. 5/4 take away 3/4. I mark off 3 sections to make the reduction and we are left with a remaining 2/4. Hi Drake, he is saying that 2/4 is equivalent to a half. I think he is correct. If I divide both the numerator and the denominator by 2, I can show that 2/4 is in fact equal to a half. Well spotted, Drake. So we can tell Francesca there is 1/2 kilogram of flour left in the sack. Let's look at another example. Here we have 1 2/6. Take away 4/6. I will use a bar model to illustrate the total fraction, 1 2/6. I notice that the mixed number can be written as an improper fraction. 1 2/6 is the same as 8/6. Let me rewrite the equation so I am subtracting like from like, a fraction from a fraction. 8/6 take away 4/6. If I reduce the number of parts by 4, there will be 4 remaining. So the answer 1 2/6 take away 4/6 is equal to 4/6. But thinking back to the way Drake noticed the equivalent fraction in the last example, I'll examine this fraction 4/6 to see if I can calculate a simpler one. I notice that I can divide both the numerator and the denominator by 2, and that will give me 2/3. 4/6 is equal to 2/3. I can say that 1 2/6 take away 4/6 is equal to 2/3. Here's one for you to do. Using a bar model to help you, subtract 6/8 from 2 1/8. Pause the video and have a go. Here's 2 1/8 illustrated on a bar model. I have 2 whole bars and 1 part of a third bar shaded. After I make the reduction of 6/8, there is 1 bar and another 3/8 remaining. 2 1/8 take away 6/8 is equal to 1 3/8. Here I have the subtraction equation 7 5/12. Take away 11/12. As before, I can represent the total 7 5/12 using bar models. There are 7 whole bars and another with 5 parts shaded. Now I can easily make the reduction of 11/12. After I make the reduction, it's easy to see that there are 6 whole bars left and 6/12 remaining. Have you spotted an equivalent fraction to 6/12? I can divide both the numerator and the denominator to make a more simple fraction. I can divide 6 by 6 to give me 1. 12 divided by 6 gives me 2. So 6/12 is equivalent to a half. We can see the answer to our subtraction calculation is 6 1/2. I want to show you another method to approach that subtraction. It can take a lot of time and space to draw so many bars to show the total fraction using bar models. This time I want to use a part whole model. 7 5/12 is the whole fraction, and it can be partitioned into 7 wholes and 5/12. Thinking back to our subtraction equation here, we have a mixed number taking away a fraction. So that I can take away like from like, I can change the 7 wholes to an improper fraction. I want to find out how many 12ths are in 7 wholes. So I multiply 7 by 12, and that gives me 84. 84 12ths. My part whole model is now showing me that 7 5/12 is in fact 84 12ths and 5/12. I can rewrite my equation now showing only fractions. 89 12ths take away 11 12ths. Reducing the numerator by 11 will leave me with 78 12ths. As you know by now, we shouldn't leave the answer to a calculation as an improper fraction. We should change it back into a mixed number. I know that 12 times 6 is equal to 72, so I can change 78 12ths into 6 6/12. But that's not all. I also notice that 6/12 is equivalent to a more simple fraction. I can divide both the denominator and the numerator by 6 to make the equivalent fraction 1/2. The answer to our subtraction is 6 1/2. Here's one for you to try. Instead of using bar models, this time have a go at partitioning the total fraction 3 2/8 to make an improper fraction and then calculate. Remember, do not leave your answer as an improper fraction. Change it back into a whole number or mixed number. Pause the video and have a go. Let's see how you got on. 3 2/8 can be represented on the part whole model like this. 3 wholes and 2/8. I want to change my 3 wholes into an improper fraction so that I have 2 parts showing as a fraction. I can do this by multiplying 3 by 8 to give me 24/8. The 2 parts to my total fraction is 24/8 and 2/8. I can rewrite the subtraction sentence now, showing only fractions. 26/8 take away 5/8. After reducing the number of parts, 26 by 5, I am left with 21/8. That's an improper fraction. Instead of leaving it as an improper fraction, I divide the numerator by the denominator to find out the equivalent mixed number. 21 divided by 8 is equal to 2 with a remainder 5. So 21/8 is the mixed number 2 5/8. We've come to the end of today's tutorial. Now it's time for you to go and get practice. Remember to use bar models or part whole models to help you work through the steps. Calculate carefully and remember, to learn you need to practice. Make mistakes and learn from your mistakes. Read and understand the feedback. As always, best of luck!